Okay, in this video, we're going to talk about some basic software development concepts associated with C#. Now, when you're learning C#, it's very easy to get confused very quickly when you see all the different syntax and functions and all the different terminology used in C#. But one thing I like about C# is it's designed around modeling software as if it was a real-world object. And we'll talk about that, but if you understand that idea of modeling things as simple real-world objects, it makes all of that complex terminology, suddenly it makes a lot of sense. So if you understand these basics, it might help you a lot in understanding what everybody's talking about when they're talking about C#. Now, one of the things that's intimidating is that the software applications are used in many, many different areas. And for example, communication, you've got emails, instant message, Facebook post, all of these applications doing communications. Entertainment, video files, music files, photos. And in the real world, the industry, you've got different transactions using software applications, banking transactions, transmitting information between clients and servers. Online purchases, Amazon, eBay. And in other industries, you've got control. For example, production lines. When you're manufacturing everything from cars to airplanes to computers, those are all manufactured on production lines, and the industries control those production lines using software applications. And the same thing for power systems or traffic lights. Anything that's controlled uses software applications. And then monitoring. There's a lot of monitoring using software, such as air traffic, where they monitor the position and speed of airplanes. Weather, monitoring the weather throughout the United States and around the world. Stock market. And then in designing and manufacturing equipment, most industries use simulation, software simulation, in their design process to figure out how best to design. And you also simulate weather to predict it, and designing equipment, you simulate it. But while that may look very intimidating and complex, it really comes down to transmitting and receiving characters and image and sound files. I mean, emails, instant messages, Facebook posts, those are all characters and image and sound files. Same thing with entertainment, video files, music files. And then transactions are basically characters going back and forth, and so on. So again, it's intimidating and might be confusing, but really it comes down to transmitting characters and image and sound files. Another interesting and useful concept is to look at the idea of a book in the real world. And inside the book, there's a lot of information. And there are many different types of books that have all different types of information. You've got reference books, you've got novels, you've got all kinds of books. But really, inside those books, if you boil it down, it's basically characters and images. So again, there's a lot of complicated stuff in here, but at the basics, it's characters and images. And really, when you get into your computer, in the software world, in the hardware world, it's all converted ultimately to ones and zeros inside your computer. So there's a lot of complex stuff here, but it comes down to ones and zeros. So the first thing I want to talk about to try and simplify this is the concept of libraries. And libraries are used throughout software development, especially in C#. In its object-oriented design, libraries are very, very important concepts. Here I've got an image of the Library of Congress, which is one of the largest libraries in the world. It's got millions and millions of books. So it stores a lot of information inside this library. And inside any library, especially Library of Congress and any other library you walk into, you will see all these books arranged on shelves in what are called stacks. And you can wander through these shelves, through these stacks, and find the particular bit of information, the particular object, book that you're looking for, grab it off the shelf, and use it to get whatever information you want. And these books are available 24 hours a day, 7 days a week, and they are there for your use. You just find where they're located, grab the book, open it up, and you can use it. And then you put it back and somebody else can use it. So it's Very useful and functional arrangement of information that you can use. You just have to reference it and it's there. Now, the other thing that you'll see inside a library is what's called a card catalog. Now, in most libraries now, these physical card catalogs have been converted to computer database. But the concept is the same. Every book in the library has a card associated with it, located in these physical card catalogs. And the card catalog is basically just drawers with these cards in them, listed alphabetically. So you find, if you're looking for a book, you alphabetically find the right drawer, open the drawer, and then sort through the alphabetical listing of cards until you find the card for the book you're looking for. And that card will give you the address and tell you where in the library to locate that particular book. And if you look on the book, every book in the library has got that address that is listed in the card catalog on a printed sticker taped to that book. So you can find the address in the card catalog and you can locate that book inside the stacks. So let's take an example. Let's say you want to go into a library, you want to find a book somewhere in those stacks, and in this case, you want to find a book called The Filmmaker's Handbook. So how do you do that? Well, you could look through all of the stacks for days and days or weeks and weeks until you find the book, but a better way is to go to the card catalog. So you go to the card catalog, you find the alphabetical listing of the book, you pull out the drawer, you sort through until you find the right card for your book, and it will give you an address. And in this case, for this book, The Filmmaker's Handbook we're looking for, the address is 778.53 ASC. So you find the address, you write it down on a slip of paper, and you then venture into the stacks. In this case, we know we want to go to the 700 section since it's 778.53. We first go into the stacks, find the 700 section, which might be on the second floor or the third floor. And once you get into the 700 section, you then go into the 78.53 section. So you find where that section is. And once you get the right shelf, the right section and the right shelf, you will look through the books and you will find 778.53. So you have referred using an address to that book, and now you have located that book. And at that point, you have found your book based on this reference number inside a catalog in the library. So that's a very important concept. You have an object you're looking for, a data object that's got information. To find it, it is located at an address, and you find the address, you refer to that address, and it leads you to the location of the object. Again, a very important concept when we get into the software world, but it models basically a library in a real-world library. In the software world, it's not only a book with characters and images. In software, this object may also do stuff for you. It may have methods or functions that actually performs things for you rather than just being a passive book. So there's a lot more functionality in the software world, but again, the concept is the same. You refer to an object that has function and information, and that's how you access it via this address. Now, to expand the analogy, comparing the software world and the real world of a library, we saw that the book we're looking for is in the 700 section. Actually, there are numerous sections in the library, and each section has a different class of information, okay? A class of information is a group of information, and in the real world library, there is classes of information that are numbered from 000 up to 900. Ours was the 700 class of information, and that is the architecture, art, and photography class or section of information. In the real world, The different classes are, for example, encyclopedias, journals, and news in the 000 section or class. The 100 class, which is philosophy and psychology. The 200 class or section, which is religion and churches, and so on. So all of the information, the available information, is broken down into classes or areas of information. Now, in the software world, they are called class libraries, which is very similar to in the real world libraries. You've got your classes of information. And Microsoft has also called them namespaces. Now, it's kind of counterintuitive calling them namespaces, but it's the same idea. You classify information with an address so that you can reference the class and the address to get your information. So that's what a class library or namespace is, basically a class of information that you can refer to. Available information that you can refer to. All you need is the address and to know where to go. So in the software world, we have, on the right here, we have what's called the .NET class libraries, basically the Microsoft pre-built libraries that people have already written the books of libraries of information that you can access. Very similar to books in a library, there are these classes, and in the .NET library, just some of the classes I've noted here, but there's many, many more. There's the system.speech class, which has speech synthesis functions and speech recognition that you can access, you can refer to. That's pre-built functionality. They're just sitting in these libraries on your computer. There's system.windows.forms that allows you to do forms, Windows forms. System.threading that allows you to have multi-threaded processes. System.drawing that has graphical functionality, and so on. But basically, you've got these books in the library, functional books in the library, in the different classes, just like we had the 700 class or the 200 class. And they are located ready for you to access. All you need to do is cite a reference from your main application. Here I've got your app as your main application, and you just need to reference these pre-built .NET class libraries. And again, the analogy is, I've got the Library of Congress here, but on your computer, it's like the Microsoft .NET class libraries. And inside that, you've got the books in the stacks on the shelves that are ready and waiting for you to use. All you have to do is refer to the correct section and the correct address, and you can use those libraries in your main application whenever you need them. And again, in the .NET class libraries, we can make the analogy to the library the address in the library that we use to get to our book. We use 778.53 ASC. And if you make the analogy to the class libraries, we're going to the 700 section, which is as if you had a system.arts class library. And in the 770 subsection is like the system.arts.photography section of the class library. And the 778 subsection is system.arts.photography.specific subsection, which is how they are defined in the real world libraries, these subsections. And it's the same as the class library addresses in the .NET class libraries. So it's very similar to how they define libraries and addresses in the real world libraries. The .NET class libraries are set up very similarly. Now, as we get into the libraries, we said the books are like objects in that library, and they have functionality, and they have characters and images, and they actually do stuff. So now we're going to talk about the objects themselves and how they are configured. So we'll start out taking an analogy of a car. Say we've got a car and we are going to treat that as an object. Now, in the software world, you can treat just about anything as an object, And the reason you want to do that is because it makes your code very easy to understand. You can segregate things into objects, and you can work with those objects using very simple interfaces, and the objects will do stuff for you, and you just have to access them, just like a book in a library. The book in the library has information. You just have to access it as an object. You just refer to it, and it does stuff for you. Now, in the real world, you have people who can do stuff for you, like an assistant, for example. But in the real world, you want to be careful about treating people as objects because, you can get in trouble if you objectify people. You want to treat people as human beings and be respectful. But in the software world, it's actually better to treat anything as an object, even people or cars or airplanes, whatever, because in the software world, if you're going to model things, if you treat them as an object, it makes your code very reusable and easy to understand and very simple, as we'll see. So that's a major concept in software development. It's called object-oriented software development, where you treat things as objects, and we'll see why that's such a good benefit. So if we look at a car as an object, it basically has a single primary function, and that is to drive you places. Okay, so it's a function, a simple function of driving. To make it do that, it has inputs that the user has to apply to the object to make it do its thing. So for example, it has a steering wheel that tells the object how to go in different directions. You turn the steering wheel and you go left or right. It also has a gas pedal, and the user presses the gas pedal to make the car speed up. It also has a brake. You hit the brake to make the car slow down. So the interfaces, these are called interfaces. They interface with the car to make it do its things. These are inputs to the car that the user has interfaces to make the car do its thing. It makes it very simple for the user. All I have to do is turn the steering wheel, press the gas or press the brake to make the car do its thing. So if we convert that car into a simple object, we have an object of a car. It has a primary function inside of it, and that is to do driving. But to do that, it needs to have three primary inputs from the user to tell it how to do its job. Now, in this box, the user doesn't care how it does its function. Okay? All the user cares is I turn the steering wheel, I press the gas, I press the brake, and the car will do what I want it to do. But the user doesn't care or doesn't need to care how it does that function. That's up to the manufacturer to make sure that it takes those inputs and does what it needs to do. The user doesn't need to care about the fuel system, about the ignition system, about the brake system, the hydraulics. The user doesn't need to care about that. It just needs to use these simple inputs and do his job with these inputs, and the manufacturer has already figured out how to convert those inputs into the function of driving. Now, on the other hand, if you are the manufacturer, you certainly had to design this box for this function of driving. So you had to know how to convert these inputs into what the car needs to do to drive. So if you're modeling this, you certainly need to convert this driving function into a lot of different other functions to make it do its thing. But this is a very important concept that is used in object-oriented programming, which makes this such a very important function. And one other reason why is you'll start to realize that function of driving is done by not only a car, but in the real world, other objects do the same thing. For example, we have a truck here, which is an 18-wheeler truck. It does exactly the same function. It does driving. It's a different object, but it does the same thing, driving. It has the same inputs, steering, gas, and brake, but you can see it is a completely different form of object. It's got a different number of wheels. It's got 18 wheels. It's got this trailer with a lot of storage in it. It's got different ways of doing it, different color, different size, different from the car. But basically, when you boil it down to a function and inputs, it's virtually identical. And the same thing goes, for example, for a motorcycle. It does a function of driving. It's a different object, but it does the same function of driving, and it has this exact same inputs, steering, gas, and brake. The form is different. It's got handlebars instead of a steering wheel. It's only got 2 wheels. It's got a different size, different color. But when you boil these down, these are very similar objects in that they do very identical functions with almost identical inputs, but they just have a different form, and how they do this function internally is quite different. But at the end of the day, it's all the same ultimate function and the same similar inputs. So what we can do is we can put all of these different objects with different forms but the same function and inputs, put them into what we call a class of vehicle. They all belong to this general class of vehicle that does driving and has identical inputs, and they are different forms, different properties, but they all belong to a class of object called a vehicle. Okay, so you can see that a vehicle can be defined as anything that does driving and has 3 inputs, steering, gas, and brake, even though they have different properties and different forms and may do this function differently, but basically they belong to these class of objects. Again, this is an extremely important concept when doing C# or any object-oriented programming, and one reason why it makes it so nice in C# that you can view things as objects that are very simple objects with inputs that make your code very much easier to work with. You can segregate things as objects and only deal with them as you want, and it really makes your code a lot easier to understand. So again, the concept is to break things down into objects with functions, and they may have different properties, but they also have inputs, outputs in some cases. But if you can break things down into this concept, your code becomes very, very simple and easy to work with, and you can reuse this over and over again. Now, one other concept you might see in object-oriented programming, such as C# or any other, is the concept of an interface. And this can be somewhat confusing to folks, but really it's based on a fairly simple principle. Now, when we developed our vehicle class previously, we said all vehicles in that class must have steering, gas, and brake, or else they're not vehicles. They must have a way to turn, to accelerate, and to decelerate. So an interface is basically a way of saying that if you ever develop a specific vehicle object, such as a car or a big rig or a motorcycle, it must have some type of functionality inside of it to do steering, gas, and brake. Now, we don't care how you do that. We just care that it must have some sort of implementation and an external interface to those separate functions within the object. So it's one way of making sure that it is truly an object in that class, and we are defining that it must maintain those properties, that functionality in order to be a vehicle. And it just helps down the road when people are developing objects from that class to make sure everything is consistent, and people know if they're going to develop a vehicle, they need to have steering, gas, and brake, and everybody knows what the rules are. Now let's take another example. We've got a passenger airliner. It also drives you places, and it has a function of driving. It has properties that are different from of course, an 18-wheeler or a motorcycle, but it also has inputs, and in this case, it has outputs. So we'll take a look at some of the inputs and outputs. It has pilot controls. He controls the fuel to the engines. He controls the flaps, the steering. Again, those are the inputs. They are different, but they are very similar. They are required in order to control the vehicle, which is the airplane. And in this case, it has outputs. The outputs can be viewed as for air traffic control. The air traffic controller needs to know every airplane's speed, elevation, and position so that they can maintain control over the air traffic system to make sure nobody crashes, nobody collides with another airplane. So they need to have this information. So that is fed out through the radio transponder to the main air traffic control system. That information is an output from each object sent to the air traffic control system. So again, you're boiling things down to an object with functions and properties with inputs and outputs. Again, an extremely important concept. Now, I do want to mention, however, that while object-oriented programming is extremely popular and seems very logical, it's your job as a software developer to decide to what extent it is appropriate for whatever software you're developing. There is another approach that was very common prior to object-oriented programming, and that's called procedural programming, which is basically a more step-by-step as opposed to making everything into an object with function and properties. You may find that in some cases you might want a more procedural approach as opposed to an object-oriented approach, because maybe some abstract concepts don't really fit into the object-oriented approach. So that's just something to keep in mind. Usually there's not always a perfect solution that's always right in every instance. So it's your job to figure out what's the best approach. Now that we've defined our libraries and we've defined our objects, let's look inside the objects at the functions that they perform. Now, Microsoft, again, has given a more or less intuitive terminology. They call this methods, but functions and methods are about the same, and functions are the things that objects do, and methods is just another term for that. So, when we're talking about functions, let's define what that is. Now, here I've got two people interacting. I've got a supervisor, and I've got his assistant. And the assistant, I'll call him the adder guy, and in this case, the assistant's job is just to add two numbers. So, for example, the supervisor will tell the assistant, in this case, I want you to add the number 126 to the number 254, and when you're done, come back and tell me the answer. So he is feeding information to the adder guy, and the adder guy's job is to take those numbers, perform the addition, and come back to the supervisor and tell him the answer. So, again, if we get back to this object concept, the input to the object is two numbers. The output is the answer after he's done his addition job. So we can objectify this person, this adder guy, as a simple box that performs a function. It takes inputs and gives outputs. So what I've done here is I've written some very simple C# code to define this function. I've called the function adder guy, and I am passing two parameters. I'm inputting two numbers inside this parenthesis, A and B, which are these input numbers 126 and 254. I pass these two parameters, or I input these two numbers. The adder guy function in C# adds them. Here's the A plus B. It adds the two numbers, and it returns the answer to the supervisor. And I have defined the answer as being an integer. So when I call this adder guy, I pass it two numbers, I return the answer, and it comes as an integer back to the supervisor. So I'm returning the answer as an A plus B. So I've got, in C# code, I've got the definition of this function as the return value, which is going to be an integer going back to the supervisor. I'm passing these input values, A and B, and I'm performing the function inside the function. Now I can expand this in C# to have many assistants or many functions. I've got an adder guy, I've got a multiplier guy, and I've got a subtractor guy. I can have a divider guy. I can have any guy I want as long as I break them into these simple functions with inputs and outputs. So here I've got C# code for each of these. I've got an adder, multiplier, subtractor. They're all returning A minus B, A times B, or A plus B, depending on what I want them to do. Now I can also take this concept and put all of those functions into one main function. And I can call this math, and I can feed it, I can pass it the two parameters I want it to work on. I can also pass it one more parameter that defines what actually of these functions I want it to perform. So I can pass the number 1, 126, and 254, and that tells it if f is 1, I want it to add them. So it will add the two numbers and return the result as an integer. Or I can pass it f0, 126 and 254, and it will do multiplication. Now, if I don't need a return value, for example, let's say I've got a messenger guy, and his job is to send a message. And maybe I've got a case where the supervisor says, just go send this message for me, but no need to get back to me with any response or any answer. So in this case, I've got C# where I've got a messenger function called send message. I pass it a message, and the function of this messenger is to send the message. Now, this might be 50 lines of code it's required to send the message, and the return value will be void. It will be nothing. I don't want anything to come back to the messenger. So void means don't return anything to me, back to the supervisor. So I input a message, it does its thing, and it returns nothing. Now, that concept can be expanded into libraries. Libraries of these functions that perform whatever function I want it to do, and basically I pass it a parameter, it sends back a return, and I don't care how it does what it does. I just use the functionality by referring to it, passing a parameter, and getting an answer. So I can do that with math, I can do it with communications, sending messages, I can do it with speech recognition or speech synthesis using a text-to-speech library. I send it a message, it plays it out through my speakers or headphones, and it may or may not give me a response. Again, an extremely important concept when you get into software development and object-oriented programming, where I have libraries waiting for me. I just refer to it, pass it a parameter, and it does its thing. Now, there is another concept called dynamically linked libraries. And if you look at the name of this, it's a library, again, just like we've been talking about, like a book in a library. But this is dynamically linked libraries. And all this is these math operations, for example, converted from C# code into machine language, just like you do an executable. Basically, it is after you compile it and convert it into this machine language or intermediate language, it is basically an executable, but it's missing a line that tells it to execute. It's basically machine language that's made from your C# code. So basically, I've got my C# code sitting in a .dll library file that is ready to perform those functions. So I can have a math.dll file, communications.dll, text-to-speech.dll, or whatever I have for functionality converted into a file. And it's actually a file just like a .exe file. And it's sitting there waiting for me. And I can use that DLL for any other executable I develop. So if I develop 5 different executables that all need math operations, I can refer to that one math DLL with each of those executables if ever I need this functionality in the DLL. Again, an extremely important concept that I can dynamically link from my exe file into any DLL that is sitting there waiting in my library. So again, in the software world, the concept of libraries. I've got my main C# code, and I can refer to all of these libraries sitting on my computer, whether it's a .NET framework library or my own DLLs that I compile and make into DLL files. So in the .NET framework, I've got file operations libraries, which is basically DLLs to, if I need to do file operations, I can send a request to the file operations library and feed it some information. It will go open up and close and access files. Same with drawing. If I need to do drawing graphics, there's DLLs that are sitting there in the .NET framework libraries that will help me do my graphics. Same with speech recognition or speech synthesis. And there's many, many, many DLL framework libraries sitting there that I can access. So I've got a lot of functionality when I write my code so that I can always access these instead of, reinventing the wheel every time I write C# code. I've got these DLLs available that I can just access as needed from any executable I write. So again, the main concept, I've got a library. And in this case, maybe we can see it as a Microsoft library. And inside the library, I've got the .NET Framework DLLs, which are basically books in the library that I can access. All I need is an address to refer to. And in these books in the .NET Framework DLLs, I've got these data objects, which is basically C# functions, just like books. I pass it parameters, it returns a value, and I've got these many, many, many data objects that I can refer to. And as we said, not only do they give us information, they can do functionality. And actually, these .NET Framework DLLs are sitting on your computer in this directory, and there may be other directories too, but if you go to the C Windows Assembly directory, you will see a whole bunch of .NET Framework DLLs, system DLLs, the same things that you use when you write a C# program. You do using statements to refer to those files sitting on your computer in the .NET Framework, the DLLs. And this concept of libraries and addresses and data objects also applies in the memory of your computer. So it's not only in software development, it's actually in the lower level memory, the RAM of your computer, where we have stacks and heaps. And again, we talked about stacks in a library. The arrangement of your RAM in your computer is the same concept. Your memory is arranged in stacks and heap, or the part of your memory is arranged in stacks and heaps, which is basically you have pointers, which are addresses that point to objects in memory, such as if you have an integer, you have a pointer to the location of that data, which is the value of the integer in your memory. So that library with stacks and heaps also applies to the memory in your computer. And outside of the stacks and heaps in your memory, you've got just memory that's used for storing data, but it's all basically addresses with data inside those addresses. So basically, that is those are some of the very basic and very, very important concepts surrounding C#, object-oriented programming. And as you're learning C#, if you think back to those basic concepts of objects, performing functions, objects with different properties that have inputs and outputs, and do functions and methods, that will help you when you look at all the different syntaxes and all the different functionality in C#. It's basically designed around what we've been talking about, data objects in those formats. So I hope this has been helpful. It should help you to boil down a lot of what you're learning in C#. And have a good day, and hope to see you in the next video.